In this video, you will learn how to predict the most likely ions present by just reading the procedure. We will use a UCE examination paper in this demonstration. Before you start the experiment, read the procedure 2 to 3 times, and also scan the laboratory to locate all the required reagents. You will be provided with an unknown salt or mixture of salts, and required to determine the cations and anions present. We will go through step by step. Clue 1. The salt X provided contains 2 cations and 1 anion. This implies it is a mixture of 2 salts having different cations but the same anion. 2a. Note the physical appearance of the salt before heating, and also, note any color change of the hot and cold residue after heating the solid. In addition, sense any smell and color of gas evolved where applicable. In 2b. Dilute nitric acid is added. This is to dissolve a salt insoluble in water. Please note, since the acid contains a nitrate ion, it cannot be the anion in this experiment. In this test, note the color of the solution or any gas evolved. In 2c, bear in mind that all cations react with sodium hydroxide to form a metal hydroxide. Some are precipitates, while others are soluble in excess reagent to form complex ions. Therefore, the residue or precipitate in this case contains a cation that forms a precipitate insoluble in excess sodium hydroxide. You can use the color of the precipitate to filter the list. On the other hand, the filtrate, that is the liquid portion, contains a cation that forms a precipitate soluble in excess sodium hydroxide. Again, use the color of the filtrate to predict the cation present. Therefore, 2c separates the 2 cations, one stays in the filtrate and the second one in the residue. (2d) is a reverse procedure to recover the cation from the complex. The filtrate goes back to a solid, which then dissolves in nitric acid, to form a solution containing one of the cations. Transition metal cations are easily identified by color of their salts, but the ones tested at O level form a PPT insoluble in excess. Therefore, the possible cation present is lead or aluminium or zinc, all of which form a white PPT soluble in excess sodium hydroxide. Potassium iodide solution is used to test for lead 2 ions. Therefore, test D3 would be irrelevant if test D2 gives a positive test for lead 2 ions. This implies that test D3 confirms the presence of zinc ions. In test E1, a white precipitate insoluble in excess is formed. Ions probably present include barium, calcium, and magnesium. Similarly, test E3 would be irrelevant if test E2 gives a positive result. Therefore, we expect no observable change in test E2, which leaves all the 3 ions probably present. Test E3 offer a unique outcome with calcium ions. If there is no observable change, calcium ions are present. Therefore, X contains calcium, zinc, and a carbonate ion. Always be on point, and use keywords or formula when recording your observations and deductions. Follow a sample marking guide in the next sections.